We are in the golden age of space exploration. For the first time in history, the idea of transporting human beings to other planets leaves fiction and becomes a serious matter about logistics. Of these other planets, one is particularly attractive and will likely be the first target of interplanetary colonization by humans: Mars. Before you pack your bags and board a ship bound for the Red Planet, you should ask yourself, would you be younger or older on Mars? In physics, the best-known paradox is a direct consequence of the theory of special relativity, presented by Albert Einstein in 1905. In this paradox, a space program separates two identical twins. The twins remain on Earth while the other enters aboard a ship traveling at relativistic speeds. The term relativistic speed refers to a speed close to but never greater than the speed of light, which is 299,792,458 meters per second. To allow our astronaut twin to experience time dilation in all its brilliance, this is crucial. He returns to Earth and finds his brother after 10 years traveling in this rocket. But, to his amazement, he only aged 10 years while his brother aged 20 years. While speed explains time dilation, gravity also has an impact on the passage of time. The focus of this video is gravity. You probably didn't understand the question when I asked if you would be younger or older on Mars, but that's normal. In physics, the world we live in is called the Newtonian world. Physicist Isaac Newton proposed the laws of motion to describe the Newtonian world. And it was thanks to him that our understanding of our world and the universe improved. Furthermore, the world around us is the key word. Newton could only make observations here on Earth. One of his best-known stories is about an apple falling on his head. Even though this story isn't true, it teaches us a lot about the world Newton imagined, which is actually the world most of us imagine. In our daily lives, simple things like an apple falling from a tree, a person pedaling a bicycle, or a stone falling into a lake, causing waves, are common things. The difference between them and the absurd gravitational field of a black hole is that they all occur at low speeds and in weak gravitational fields. The laws of motion, which allow us to make predictions about the world, were created by Newton, who was the first to provide a deep mathematical meaning to all these things. But as technology advanced over the centuries, a curious phenomenon that had never happened before began to happen. Technology allowed us to see much further than the world around us. This applies to both the micro, small things like atoms and molecules, and the macro, the large structures that form the universe. Increasingly powerful telescopes allow us to see further into our solar system, and increasingly small microscopes can see the tiny parts that make up matter. In response to these changes, the theoretical area of physics has also advanced. Physicist Max Planck, who discovered electromagnetism and discovered that light is an electromagnetic wave, is an excellent example of this. As a result, it began to become evident that Newton's physics has limitations at micro and macro levels. A young physicist began to question Newton's equations. Furthermore, there was something that irritated him. This physicist was the same as Albert Einstein. In Newtonian physics, the perception of time was one of the things that bothered Einstein the most. Newton believed that time was something absolute that worked uniformly anywhere in the universe. At first glance, it makes perfect sense. The time on my watch is exactly the same if I ask my neighbor what time it is in his apartment. And we can go further. For example, if I combined all of you watching this video to count exactly 5 years from now, and we should all meet at the NASA Launch Center. We would all arrive at the same time, as time would pass for everyone, regardless of where we are. Time is absolutely the same throughout the universe, so Newton wouldn't care if he was close to a black hole. However, something warned Einstein that this could not be true. He investigated this subject deeply until he reached a conclusion that changed history. Time was not absolute, but relative. At first, Einstein came to the conclusion that time was relative to the speed of things. Time passes slower for those who stood still the faster you move. The special relativity of 1905 led to this as one of the most significant results. Over the years, Einstein discovered that time was not just relative to speed. He discovered that time could be distorted by equivalent mass or energy. He went even further. Not only did mass have the ability to distort time, it also had the ability to produce gravity, a time distortion associated with space. Until then, the more mass is concentrated in one area, the longer it will be distorted. Furthermore, the position of the body in this curvature is relative. Basically, it's this: if you are in a region with more intense curvatures, like a black hole, the distortion is being made more frequently and the effects of that distortion will be more intense. Additionally, the impact will be less strong the further away you are. Also, you may be wondering, how do I know where I am in the warp of time? A way to calculate the distance you have to the center of mass of the most massive object closest to you. In our case, the Earth is the object that causes the most distortion and severe impact. Gravity is the distortion of spacetime that the Earth's mass causes and traps us in it. Although the Sun and the other planets have an impact, the impact is minimal enough to ignore. To calculate our distance, we can consider the Earth's center of mass, located in the middle of the Earth. Therefore, all we need to know is the distance that separates us from the center of our planet. Furthermore, if we made a pool ball the size of Earth, our planet would look more spherical than the pool ball, even with Everest and all its mountains. This is because the Earth is quite spherical. That's why we don't feel or observe the passage of time when we're at the top of Everest or in the middle of a beach. The gravitational field that is affecting you now is practically identical to the one that affects where I live. Due to negligible relativity, we can consider Newtonian physics and, consequently, time as something absolute in our daily lives. However, the effects are more visible when we move hundreds of thousands of kilometers away from the surface due to the significant decrease in the gravitational effect. Furthermore, GPS satellites need to be constantly adjusted by relativity, as their accuracy is affected by time dilation. You couldn't use GPS in your car if we didn't know about relativity, because the GPS error would be in the kilometer range. Although these effects are small here on Earth, they become significant at a certain point. And Mars? The small planet next to us is much smaller than Earth and has less mass than our planet. Is the time on Mars the same as the time here on Earth? The answer is clearly no, given everything I said in this video. Let's assume you've lived on Mars for a long period of time. Would you be younger, older, or the same as if you had stayed on Earth the same way? Reply in the comments field. However, things get more intriguing. Let's assume that you, astute adventurer, decided to remain on Mars for 10 years and your twin brother chose to remain on Earth. Returning to Earth after these 10 years, you are reunited with your twin brother for the first time. Who will be older? Let's just consider the fact that his twin brother has installed a very sensitive countdown with 10-year intervals. We can calculate that 10 years are equivalent to 3.156 by 10.8 nailed seconds. Up until this point, his brother had set the countdown to make sure nothing was delayed. Upon arriving on Earth, his brother is scared because his watch has not yet beeped and the count has not yet reached 0. Time passed normally for you. Your clock shows that you are counting 10 years on the dot. When this happens, you discover that time has passed differently for you and your brother. You are actually older than your brother. You spent more time than your twin brother. But how long was this different? To make the calculations easier, we will only mention the effect of gravity. Speed would also have an impact, but that will not be considered in this video. By substituting the values for the radius, mass and due constants of Mars into this beautiful equation, we arrive at a value of approximately 0.04 seconds. Maybe a little smaller than the expectation was. This means you are older than your brother by less than a second. The difference is not visible. If, for example, you choose to go to the edge of a black hole or a neutron star, this difference may be more evident. However, it is useful to remember that when it comes to relativity, who is it relative to? Due to the fact that your time on Mars would pass naturally for you, and even if you lived on Mars all your life, you would never know that you aged more than your brother on Earth. Like the time his twin naturally spends on Earth, the difference is only visible when they meet and compare their values. And that's something incredible, how time passes differently, we don't even realize it. It's as if we don't know what time is, and, to be honest, we don't really know. Although it's just milliseconds, Pedro, it's impossible to compare. However, consider that the equation is equally applicable to the most distant objects in the universe. Furthermore, spending a few years living on a planet close to a black hole could be equivalent to hundreds of years here on Earth. This is exactly what happens among the stars. It's almost like time travel, which would only last a short time, depending on where you are. In other words, the most important takeaway from the video is that a time machine that lets you travel to the future is just a rocket that travels at speeds almost as high as light. Or it's simply standing still in a place where the gravitational field is extremely strong. So it seems that time machines are no longer just science fiction. However, what if you could travel to Mars? Would you be willing to be the first human to inhabit the red planet? What do you believe you would most like to remember when you are here on Earth? Write here in the comments. My gratitude, and until next time.